Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to Haseeb Electronics. Friends, this video is a special requested video, demanded video from one of my friends. He asked me, sir, this is respected sir, I am subscriber of your English and Hindi Urdu channel from last 6 months and regularly see your videos. He said, I have this 12 volt 1.5 ampere circuit board. He need to explain it. This is the circuit. This is input side line and neutral. Here is NTC box capacitor. Then there is MOV voltage arrestor. Then there is dual line filter, bridge rectifier. After that there is a resistor and we have adjustable voltage regulators, and then there is SCR. After that there is MOSFET. This is main capacitor, and after that there is SMPS transformer, high frequency transformer, and in this area there is optocoupler, and this is output section, one rectifier, second rectifier, two capacitors, maybe one inductor and the second inductor, and class Y capacitor. And here is TL431. This is the print side, and if we see the print side, here is SMPS IC, some supporting components, current sense resistor, R9 ABC, 3 resistor in parallel. These are connected to this SMPS controller, and here is 3 resistor R10 ABC. These are working as a snubber circuit. We will see the diagram. He also mentioned send message. I have this diagram and I want to see why SCR C106MG is used in this circuit. What is the function of this SCR? He sent me this message on 5 October, and I am sorry for late because it is now about 15 October. The top left corner we have phase and neutral. There is a fuse 3.15 ampere. Then there is NTC. After NTC we have 2 resistors, 1 capacitor, voltage arrestor, and this dual line filter. This circuit is working as a noise removal, high frequency harmonics, as a low pass filter, for 60 Hz. It will remove the high frequency and it will block, and this line filter will also store energy to compensate the circuit requirements. And this NTC is used as a surge protector to protect from inrush current. AC and AC, 2 terminal are for AC input of the bridge rectifier. Either it is a bridge or either it is used using 4 diodes. So we have positive and negative output. Positive output is connected directly to the capacitor, but negative line is connected to one SCR. Before cathode there is one line going out to this capacitor, that is 100 volt capacitor C3, the small capacitor. C3 is here, this outer capacitor. It will charge at a limited voltage. What will the voltage level? Here are some resistors, R3, R4, very high value 220k and 147k. So it will drop the voltage, and voltage will charge at this capacitor about 20 volt, 30 volt, like this. Then we have 2 resistors here connected to this negative line directly here, and this positive line after passing through these resistors. So that means these 2 resistors are dividing the voltage coming directly from the output of the bridge rectifier. Voltage divider network resistors will generate a voltage reference at pin number 1 of this adjustable zener regulator 432. Pin number 2 is connected to ground directly, so at a specific voltage level. My friend did not mention the value of this resistor. So at specific voltage level, for example, when the voltage level will reach at about 200 volts DC, that time, for example, we will receive 2.5 volt reference at pin number 1. Then this voltage regulator will give a offset voltage. It will give a offset level to pin number 3. So pin number 3 will connect to this zener regulator ZD1 R6. So we can say it will give a trigger voltage. When it will give a trig, when the voltage will reach at 200 volt, for example. For example, when there is a limitation that this circuit will not work less than this voltage, so that means it is working as a remote switch, level sensor. So it will trig, and that time when this circuit will activate, the SCR will conduct, the ground will pass to this capacitor, main capacitor, bulk capacitor. So this capacitor will receive ground level. Before that it was receiving just positive voltage, and ground line was disconnected through this SCR switch. It is working as SCR switch. It is to ensure a specific voltage level. After that, this voltage, now this ground will applied to this IC. This is primary ground. This ground is connected to this optocoupler, this capacitor, this winding, these resistors. Positive line is connected. This positive 400 volt are connected directly to the transformer primary winding. When the primary winding is connected to positive voltage, and these positive voltage are going to R13, R12, this will drop voltage and it will apply to pin number 5 as a startup voltage. So pin number 5 will take these voltage as VCC or startup voltage. So this IC must work because pin number 1 is grounded, pin number 5 is taking some voltage whatsoever. Pin number 4 is working as a current sense, current limiting resistor, and pin number 3 is RT, timing resistor, to adjust the frequency. Pin number 2 is a feedback. So feedback will work later when it will start switching. At that time this gate will be triggered. This MOSFET will switch. When it will switch, it will cause to flow the ground line from source to drain to the transformer primary winding. Now the current will start. Due to the current flow, these 3 multiplied by 2.15 ohm resistor, 3 resistor in parallel, so the total resistance is 0.7 ohm. So 0.7 ohm resistor is used to sense the level of current, how much current is passing through this MOSFET. This drop voltage across these resistors will feed to pin number 4 of this IC, and it will determine the amount of current. So now the current is flowing in the on time of this MOSFET. Magnetic field will build up and it will cut this secondary winding and auxiliary winding. So first of all, complete this section. When magnetic field will build up, it will cause to induce voltage in this winding, and this induced voltage will rectify from this diode, and this rectified voltage will be charged at C7 capacitor. It is 22 microfarad, 50 volts. So this voltage will fed through the 100 ohm resistor to VCC pin. So now this IC will go in working condition. First it was in startup mode due to these VCC voltage coming through these resistors. Now it is receiving a voltage from this VCC winding, so it will maintain its switching. The meantime, it is also taking the current information. When it is switching, secondary side will also take voltage due to induction. So this induced voltage will rectify through this rectifier, and there is balancing capacitor and resistor, and this voltage will apply to this capacitor. Secondary ground and primary ground are balanced through this class Y capacitor to remove the noises, harmonics, all noises due to induction, due to load, due to surge currents. These are grounded to the primary main ground. Secondary ground and primary ground are balanced and all noises are bypassed through this class Y capacitor. Now we have voltage at C12 capacitor. L2 inductor after the C13 capacitor, this 680 microfarad 16 volt capacitors. Dual line filter. Then we have feedback circuit here. Then there is C14 and we have output circuit, feedback circuit here. Positive 12 volt through this voltage divider network is connected to pin number 1. Pin number 2 is connected to ground through this line. So pin number 2 is connected to ground. Pin number 1 will give a reference of 2.5 volt, and that time when 12 volt will arrive through this voltage divider network, that means it will apply offset voltage. Here is some error in this diagram, so we have to skip this error. Pin number 3 is connected to pin number 2. Pin number 3 of this adjustable zener regulator TL431 is connected to pin number 2, and pin number 1 is connected to resistor, and resistor this end should be connected at this point. R19 should be connected to this point to take ripples from this capacitor. So consider this, that this line is not connected here, it is connected at this point or this point. Positively it is connected here. So this optocoupler will conduct at specific voltage level. When it will switch, it will conduct this pin 3 and 4, because when it will receive the light, activation light at activation window, so its internal resistor will decrease, so that pin number 3, ground at pin number 3 will connect it to pin number 2, and this level will changing all the time due to the ripples in the output of this circuit. These ripples will be translated into varying light, and varying light will cause to change this resistor as a varying resistor. So this varying ground, depending upon the amount of ripples, will apply to pin number 2. So based on this ripples, these ripples at pin number 2 information, pin number 4 the current information, and pin number 5 the VCC voltage. 1, 2, 3. These three informations will be used to adjust the duty cycle, the pulse width of this pin number 6. So it will ensure the regulation. Here we have Snubber circuit, protection circuit. This circuit is used to protect the winding Y. In the T on, when this IC is switching, it will cause to flow the current in this primary. It is switching. When it will switch, it will cause to induce voltage at that time, because this end is grounded, so this diode is reverse bias. But when this MOSFET is off in T off period, what will happen? The magnetic field will collapse, because the flowing current is stopped. Now the magnetic field will collapse. When it will collapse, it will cause to induce reverse voltage with respect to this primary voltage, main voltage. So this reverse voltage will become in series, so voltage stress will increase on this MOSFET drain. To remove that excessive voltage in reverse polarity, this Snubber circuit is used. So it will, the diode will in forward bias at that time. First this end was negative. Now when the magnetic field is collapsing, this end becomes positive and this end becomes negative. So this positive end positive voltage have only one way to discharge. So this voltage will discharge through this path because it have only one path, because diode MOSFET is in off condition. So just only the positive voltage will complete their path in this way. Current in the primary will be zeroed and stress on the MOSFET will decreased so that it will get ready for the next switching. What are the possible causes? If we cannot find voltage, AC voltage here, might be the fuse is open, might be the NTC is not working. If fuse is blowing again and again, possible reason class X capacitor is short, possible reason MOV is short, might be bridge rectifier or capacitor or this MOSFET are short. Check this component if the fuse blows again and again. Then if we have DC voltage at output pin of bridge rectifier, positive and negative, and we cannot find the voltage at capacitor, so that time our SCR is not working, or our regulator circuit, our sense circuit is not working, it is not triggering the gate. For testing only, just for testing, make a jumper between cathode and anode pin, cathode and anode pin, or just make a jumper from negative of the bridge rectifier to the capacitor negative line. So if the circuit starts working, we will ensure that this circuit is not working. So you have to troubleshoot this area. If making jumper from here, this circuit is bypassed and the next circuit started working, so that means we have to check this capacitor, because most of the time the electrolyte capacitor becomes weak. Possible this capacitor is not maintaining the charge. If it is not maintaining the charge, it will also cause to failure. Check this capacitor, and we have to see this voltage regulator, this zener or SCR. These components are key components in switching because it is used in level sensing. Next we have here, if IC receives ground, receives VCC, you have to check pin number 1 and 5. If we have voltage here, this IC should start. At that time, if it is not starting, you have to check these resistors. This 0.7 ohm resistor is as a jumper resistor, just only very limited voltage will be dropped on this resistor. You have to check in off condition, you have to check the resistor, these resistor and these resistors, and you have to check the feedback circuit. If the circuit is fluctuating, check this diode, 1, 2, 3 capacitors, these capacitors, and check this optocoupler. So our circuit should start. If we have fluctuation, check this capacitor, C7 capacitor, VCC capacitor. If it is open from inside, most of time it is open, it does not short. In rare cases it becomes short, but most of the time it is open. When it is open from inside, it will not store the charge, so IC will start fluctuation. Sometime we find the dropped voltage in output. For example, 12 volt circuit, it is giving just only 2 or 3 volt. So possible cause is this snubber circuit. If the diode is open, it will not discharge fully this winding. So again this IC will start switch and MOSFET will switch. So the already existing magnetic field, present magnetic field or the flowing current will cancel the new magnetic field. So it will not build properly. So we will find the dropped voltage or fluctuation in the output. So check this circuit, because it is protection circuit. At that time there is a stress and this can also damage this MOSFET. So I hope so this video is informative for you. If it is informative, you can like, and if you want to watch my future videos, then you can subscribe my channel And if you want to watch my videos, you can press bell icon button if you want. If you have any suggestion, if you think there is something to be improved in this video, kindly let me know in the comment box. I will be waiting for your valuable comments. And if this video is good for you, if it is informative, please hit the like button. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.